we're going to work on row operation to getting into this. And since we put x coefficient in the first column, y coefficient in the second column, z coefficient in the third column, therefore, once we get to this is x. So x equals to C1, y equals to C2, z equals to C3. So that's what we want. By looking at this, we need to have this guy to be 1, right? So I'm going to just multiply -1 to the first row. So R1 times -1 and put it back to R1. Then we have 1, -1, 1, and 0. So now we have 1. That's the first thing we want to do. Second, all the number below, we want to make them to 0. The third row is already 0. The second one is not. Therefore, we have to use R1. Okay? R1 times 3 and then add to R2. Put it back to R2. R1 times 3, 3, -3, 3, 0. And R2, -3, 0, 5, -10. Add this 2, that'll give us this number, 0, -3, 8, -10, and then third one, 0, -6, -5, -27. Next, what we want to do, second row, second column, we want to make this to be 1. How? And do R2 times -1/3, put it back to R2. Then we have a 0, 1, 8 over -3, 10 over 3. So -10 over -3 is a 10 over 3. So now we have this 1. We have to use this second row to make above to be 0, below to be 0. So I'm going to multiply R2 times nothing, well, just since we're multiplying, 1 and add to R1, put it back to R1 so that we can make the first row, second column, 0. So 0, 1, -8 over 3, 10 over 3, and then first row 1, -1, 1, 0. We add, result is going to be here. That is 1, 0, 3 over 3, -5 over 3, and over 3. To make this -6 to 0, multiply R2 times 6, and then add R3, put it back to R3. So 0, 6, 6 times 8 over -3, 3 and 2. It's going to be -16 times 6, 3, 1, 2. It's going to be 20. And then R3, we have a 0, -6, -5, -27. Add, it's going to be here. That is 0, 0, -21, -7. So now, what do we need to do? Do we need to make these guys to 1? So in order to do that, we do R3 times -1 over 21, and then put it back to R3. 0, 0, 1, 1 over 3. Now we have to use this R3 to make this one to be 0, this one to be 0. So we want to use R3 times 5 over 3 because first row, third column is negative 5 over 3. So we need to multiply row 3 for positive 5 over 3 and then add them up so that we can get 0. And then add to R1, put it back to R1. So R3 times 5 over 3, 0, 0, 5 over 3, 5 over 9. And then first row, 1, 0, negative 5 over 3, 10 over 3. To make it to 30 over 9. 1, 0, 0, 5 over 9 plus 30 over 9, 35 over 9. And then second row, we have second or third column, we have negative 8 over 3. So now we need to multiply R3 times positive 8 over 3 and then add R2. Put it back R2, 0, 0, 8 over 3 and 8 over 9. We have R2, 0, 1, negative 8 over 3, 10 over 3, which is 30 over 9, and add, result is going to be here, 0, 1, 0, then 38 over 9. First column is representing X coefficients, second column representing Y coefficients, and the third column Z. So our answer is going to be X equals 35 over 9, Y equal 38 over 9, and Z equals 1 over 3. Determinant of 2 by 2 or 3 by 3. Okay? So that's what we're going to work on this class, and the determinant is going to pop up again in chapter 3, chapter 2, and chapter 3 as well. So if we have a 2 by 2, so we have A, B, C, D. The determinant of A, B, C, D is AD minus BC. So 2 by 2 matrix, the determinant is easy. That's AD minus BC. 3 by 3, it's not fun. Okay? So determinant of this, as you can see, there are so many numbers. So many numbers. I don't want to even read this through. So first thing we want to know for the determinant for the 3 by 3, when you set the first column, first row to be positive, the sign is alternate. Positive, negative, positive, negative, positive. For row-wise, column-wise. What does that mean? Let's work on it. So you have to use that sign. So copy this down. So in here, to get the determinant of 3 by 3, watch it here, watch it here. Everybody, watch the screen. This is plus, minus, plus, that's the alternate. So when we take this A11, that's the plus, and then A11, cross this out, and the left over this guy is going to be here. And this is the determinant of 2 by 2, AD minus BC. And then to get the second one, A12, that's the minus, right? So minus A12, cross out for the row and column. The leftovers are 821, 823, 831, 833. So now it's the determinant of 2 by 2. So AD minus BC. We're going to repeat this for 3 times. You're going to take this guy out, but this time is plus, and then cross this 0, 3, 5, 3. the determinant of this 2 by 2. We're going to work on it later. You can go with the row-wise or column-wise. You decide. I feel like want to go row-wise. So I'm going to pick row. So this one is minus. I'm going to say -4. And then cross this out. Leftovers are 6, 3, 1, and 3. Then row 7. This is the plus time. So +7, cross this out. Left 6, 0, 1, 5. 2 times AD. 0 times 3 minus BC. B is 3, 5. Minus 4. AD. 6 times 3 minus BC. 3 times 1 plus 7 times AD. 6 times 5 minus BC. 0 times 1. 2 times 0 minus 15 minus 4 times 18 minus 3. 18 minus 3, so it's 15 plus 7. 30 minus 0, which is 30. That equals to -30 minus 60 plus 210, -90, 120. Okay, let's work on it. You want to work on first row. This is plus 6. Cross this 8, -7, 4, 0, minus 5, -1, -7, -2, 0, plus 0 times -1, 8, -2, 4. So 0 times something is 0, so we don't have to work on it. So you can do this by looking at this column. There are 0, -7, and 0. So we can do using this column. That is 0 times -1, 8, -2, 4, minus minus plus 7, 6, 5, -2, 4, 0 times 6, 5, -1, 8, going to be 0, 0. So we have a 7 AD minus BC. So using this technique is really beneficial when we have 2 zeros. Right? If you have a column-wise or row-wise, there are 2 zeros you see, then just pick the middle number or the non-zero number and do only one operation. And it'll give us a 2 by 2. But if you have all, 9 different numbers, then you have to do all 3 times. Okay, so inverse of matrix. So this is the key section of the chapter. So what we learned so far to get to this. Okay, why we use this matrix? Because using matrix to get any solution, to get that, we have to use this inverse matrix. Okay, so the inverse matrix, we can get that n by n, again, square matrix, 2 by 2 or 3 by 3 matrix. We need to get 1 over determinant, whatever we just worked on in the previous section, timed a joint matrix. So we already talked about determinant AD minus BC. Okay, so we need to have a determinant calculation first, and then 1 over determinant. I'm going to call this determinant as a delta from now on. Start with the D, the Greek letter D as a delta. So 1 over delta. And then we're going to use SIPO. Okay? When you write X, you do this one first, right? And then second one. SIPO. I remember SIPO. That means this way is the sign change from, look at the comparison from determinant. You have to switch the sign for this diagonal, okay? And then switch the position for this diagonal. That's why I say SIPO. Okay, let's work on it. So let's find the delta. AD minus BC. AD minus BC. That is 10 minus 8, which is 2. So now A inverse equals 1 over delta sine position, that is 1 over 2. So 1 over 2, if you multiply 1 over 2 to everywhere, it's going to be 5, negative 2, negative 1, and 1 over 2. One of the property of inverse, if we multiply A times A inverse, we're going to get identity matrix always. Let's find that out. So A, 1, 2, 4, 10, A inverse, 5, negative 2, negative 1, 1 over 2, and multiply row by column, row by column. And we have 2 by 2 matrix times 2 by 2 matrix, inner number matched up. Result is going to be outer number, which is 2 by 2. And row by column, 1 times 5 plus 4 times negative 1. Row by column, 1 times negative 2 plus 4 times 1 over 2. Row by column, 2 times 5 plus 10 times negative 1. And finally, row by column, 2 times negative 2 plus 10 times 1 over 2. That is 5 minus 4, which is 1. Negative 2 plus 2, 0. And 10 minus 10, 0. Negative 4 plus 5, 1. So it is. And if you do A inverse times A, we'll get the same answer. Now, inverse matrix of 3 by 3. So just like what we found the determinant of the 3 by 3, we need to use this plus minus plus and then get the determinant. Okay. Once you have the determinant, we need to find each portion for the determinant. And then this is C11, C12, C13. So we have to do it all of this calculation, okay, again. So this is kind of long process for the finding inverse matrix. So I'm not going to do that. Okay? So here's what I want you to learn. Okay? For the 3 by 3 inverse matrix, we're going to write the coefficient for all those 3 equations and copy down top 2 row one more time at the bottom and then multiplying diagonal way. And then that's how we get the delta. And then we need to get the A transpose matrix first, and then copy down 2 rows to the bottom and 2 columns to the right. So here's the example the book did. It's just kind of long process. So you can take a look at it, but I'm not going to do that. So here is the same example, but following my method. I mean, I didn't invent this method, but I learned it, and I compare it with any other method, this is the best way to get the inverse matrix of 3 by 3. Okay, first find the delta. Delta, copy A, 2, 2, 0, negative 2, 1, 1, 3, 0, 1, and then copy down top 2 row here, 2, 2, 0, negative 2, 1, 1. I'm going to draw diagonal line that has to cover 3 numbers. The first one is this guy. Second one is this guy. Third one is this guy. Those are the only 3 diagonal lines covering 3 numbers, right? And going from upper left to the right side, that's all plus. So multiply them. 2 times 1 times 1, 2. Negative 2 times 0 times 0, 0. 3 times 2 times 1, 6. And now we're going to draw a line from upper right to the lower left. Again, covering 3 letters. 1, 2, 3. This time, everything is minus. Minus 3 times 1 times 0, 0. Minus 2 times 0 times 1, 0. Minus negative 2 times 2, negative 4. Now we add all these numbers. 0, 0, 0. 4 plus 2 plus 6. 12. Step number 2. A transpose matrix. What is transpose matrix? Row to column. This 2 to 0 is the first row. I'm going to put that into column. So 2, 2, 0. Negative 2, 1, 1. 3, 0, 1. Just like what we did for the delta. Copy down first 2 rows. 2, negative 2, 3, 2, 1, 0. And then first 2 column to the right. 2, negative 2, 2, 1, 0, 1, 2, negative 2, 2, 1. And then cross out first row, first column. Inverse matrix is 1 over delta. We're going to have 3 by 3 matrix here. So first column, we're going to use these 2 guys, okay? AD minus BC. So AD, 1 times 1 minus BC, 0 times 1. First row, second column, we're going to use this AD, 0 times 0 minus BC, 2 times 1. First row, third column, AD, 2 times 1 minus BC, 1 times 0. Second row, we're going to, as you can expect, we're going to go with this AD, 1 times 3 minus BC, 1 times negative 2. AD, 1 times 2 minus 0 times 3. So AD, 0 times negative 2 plus BC, 1 times 2. And the third row for these, and AD, negative 2 times 0 minus BC, 3 times 1. AD, 3 times 2 minus BC, 2 times 0. AD, 2 times 1 minus 2 times 2. So 1 minus 0, 1. 0 minus 2, negative 2. 2 minus 0, 2. 3 minus 2, so it's 5. 2 minus 0, 2. 0 minus 2, minus BC. So minus 2. 0 minus 3, so minus 3. 6 minus 0, 6. 2 minus minus 4 is positive 6. There is a way to get inverse matrix using row operation method, just like what we learned in section 2. Okay, so we have 3 by 3 matrix here, and then you put the bar and put the identity matrix, and using row operation, we want to make this guy to 1, 1, 1, and all other numbers 0. And at the end, whatever we have in the right hand side is going to be the inverse of this. And this method is going to be painful, okay? Because you have to deal with all the fractions while you're going through. I'll show you what I meant by that, okay? But when I ask you to do the inverse matrix, find the inverse matrix, you can go with this. You don't have to do row operation. But this is good review for Gaussian elimination method. So first thing we want to do, 1, 0, negative 1, 0, negative 2, 1, 2, negative 1, 3. And then using bar, then identity matrix, 1, 0, 0, 0, 1, 0, 0, 0, 1. Our objective, to make this to 1. If it's not 1, you can divide everything by that number, or you can switch them around. So let's say you are given A as 2, negative 1, 3, 0, negative 2, 1, 1, 0, negative 1. And then we want to make this to 1. But hey, if I do divide this row by 2, then I'm making all of this number as a fraction. And that's kind of pain dealing with this fraction all the time. Instead, switching these 2 rows to make this, that's perfectly fine. Switching columns is not possible, but switching rows are okay. Why? This is the system of equation. Basically, this is from x minus z equals to c1, and then negative 2y plus z equals to c2, and 2x minus y plus 3z equals to c3. So left-hand side of these 3 equations, take the coefficient, we put it into A. So switching row, meaning switching this equation, putting at the top, that's just fine, right? Switching around this equation, just fine. However, switching column, meaning you're changing x coefficient to y coefficient to z coefficient, that's not possible. I mean, if you do, you are creating different equations, but that's not allowed. Okay, so we have 1 in here. We don't have to do anything. And then luckily we have a 0 right underneath, but we have a 2. We need to make this to 0. So I'm going to copy this down one more time. 1, 0, negative 1, 1, 0, 0, 0, negative 2, 1, 0, 1, 0. And then to make this to 0, what we need to do, R1, we have to use R1. R1 times negative 2 and add R3, put it back to R3. That's going to make first column and third row, first column be 0. R1 times negative 2, negative 2, 0, positive 2, negative 2, 0, 0. There are 6 numbers. And then R3, 2, 2, negative 1, 3, 0, 0, 1. Add, put it in here. That is 0, negative 1, 5, negative 2, 0, 1. We're done for the first column. Next one, we need to make this guy to 1. So we want to do R2 times negative 1 over 2, put it back to R2. R2 0, 1, negative 1 over 2, bar 0, negative 1 over 2, 0. And we have to use this 1 to make the 0 above, 1 below. 1 above is already 0, so we can just copy down 1, 0, negative 1, 1, 0, 0. And to get the bottom 0, we need to do R2. We have to use R2. R2 times 1 plus R3. Put it back to R3. So R2 times 1. So that's R2. 0, 1, negative 1 over 2, 0, negative 1 over 2, 0. And then R3, we have 0, negative 1, 5, negative 2, 0, 1. And add that to put it in there. So when we add, we have a 0, 0. 5 is 10 over 2. So 10 over 2 minus 1 over 2 plus 9 over 2. And then negative 2, negative 1 over 2, and 1. So we finished first two columns. Next, we want to make these two 1. So that is R3 times 2 over 9 and put it back to R3. 0, 0, 1. We have a 0, 0, 9 over 2, negative 2, negative 1 over 2, 1. And we multiply 2 over 9 everywhere. So we have a 0, 0, 1. We have a negative 4 over 9, negative 1 over 9, and 2 over 9. So now we have 1. We need to use this 1 to make all the above numbers 0 to R3 times, I'm going to work on the first row, 1 plus R1, put it back to R1. So R3 we have 0, 0, 1, negative 4 over 9, negative 1 over 9, 2 over 9. R1, we have 1, 0, negative 1, 1, 0, 0. We add, then 1, 0, 0. And then 1 equals 9 over 9. So it's going to be 5 over 9. And then negative 1 over 9, 2 over 9. And then second row, we're going to multiply R3 times 1 over 2, add R2, put it back to R2, R3 times 1 over 2, 0, 0, 1 over 2, negative 4 over 18, negative 1 over 18, 2 over 18, and then R2, 0, 1, negative 1 over 2, 0, negative 1 over 2, 0. So we have 0, 1, 0, negative 4 over 18. And then second number, if you multiply top and bottom by 9, it's going to be 9 over 18. So 1, negative 1 plus 9, positive 8 over 18, 2 over 18. Sorry, negative 1 over 18 minus 1 over 2. So negative 9 over 18. So 10, negative 10 over 18. You see how messy it is? So my method is the better one.